Okay, then, welcome back to the second half of Remote Learning 8. And I thought I would do one more example involving modeling a quadratic function that is in this form where it's in this case, a t squared plus bt plus c. So we have a function with respect to t instead of x. And we'll do one more sample before I break into the new material for part 2 here. Okay, so let's get into this one, and it is that a group of friends is launching water balloons. Okay, and the function f of t equals negative 16t squared plus 80t plus 5, and this function represents the height. Okay, so that means that the output is the height in feet of the first water balloon, or for that matter, any water balloon you would think. But okay, for the first water balloon, t seconds after it is launched. Okay, so t is the number of seconds the water balloon has been in the air, and then f at t is the height. Okay, so you can sort of see or think about what would go on. You know, the water balloon would go up and then it would come down. If they launched it straight up above them, it would just go like this. If they launched it somewhere, at an angle, it would go like this. I know your eyes are probably popping over here. Now, keep in mind. Oh, so now the first water balloon makes sense. Keep in mind that this function is the model for the first water balloon, and this is some picture that isn't this function. It's some picture that they're giving us for the second water balloon, where it looks like it's the same sort of thing that's happening. We have time passing, and then the height of the balloon has been recorded. Okay, so let me get back into reading this. The height of the second water balloon t seconds after its launch is shown in the graph. Okay, so I did just do that. Which water balloon went higher? Oh, okay, which water balloon went higher? I'll get to that, but a group of friends is launching water balloons. Where is this group of friends? Could they be hiding right here? There they are. All right, so fine. Okay, just being weird for a second. Yeah, they're launching water balloons. And what I want to say about this is that while they're launching um, the water balloon is not necessarily being fired out in this like at this angle. This isn't trying to say like this is the path of the water balloon. The water balloon might very well be going straight up and straight down. This is just modeling time passing, so 1 second, 2 second, 3 second, 4 second, and building a graph with the various heights of the balloon at various time frames. Okay, so don't be thinking like this is the actual height and like it went up to this height and it went out in front of them, this length. This isn't a length. This is time passing, and this is a height of the water balloon. How far it landed away from their feet, nobody knows. Okay, so let me get into that. There's two scenarios. There's the first water balloon scenario, and that's this model. We need to find how high this one went. That's in line with the lesson from part 1. And then there's this water balloon where I can find the maximum height that it went by just reading it from the graph. Okay, so I'm going to do that first, since that's kind of easy. I'm just going to read it off of the graph, and I'm guessing a little bit, but I'm going to go with that is, what's the scale here? 25, 50, 25, 50, 75, 100, 125, and I don't know, like 130. So let's just go approximately 130 feet. Okay, so that's the second water balloon's maximum height. So now I'll find the first water balloon's maximum height, and then I'll be able to answer the question, which one went higher? Okay, so let me switch colors for the first water balloon. That's this so-called green model that's going on over here. And I'll write it down below and work on finding its maximum height. Okay, so f of t equals negative 16 t squared plus 80t plus 5. A is negative 16. B is positive 80. C is 5, but I don't need it. Okay, so the vertex's x coordinate is negative b over 2 times a. So that's looking like negative 80 over negative 32, which is a double negative, and let's see, they're both even, so that's 40/16. Wait, they're still both even, so that's 28. So they're still both even, so that's 10/4. Oh, they're still even, so that's 5/2. Slow boating my way there, but that'll work. Okay, so that's 2.5 if you prefer. Okay, so then I'm going to go find the maximum height. Oh, right. Well, I think we went over that in the first part, and the assignment reiterated it quite often. But because this is a negative value, then I know that it's one of these downward opening parabolas, right? So we know we have a maximum. But just to be consistent with what I did before, let's confirm that we are looking for a max and not a minimum. Okay, so let's see. So the max height is at this number. So we got to go get that number, and that's the annoying bit. So let's go ahead and do it. Squared plus 80 times another 5/2 plus 5. All right, how committed am I to doing this without a calculator? Well, my fraction loving friends, I'm going to do it. Negative 16 over 1 times 5/2 squared is 25/4. Plus this is 80 over 1 times 5/2 plus 5. Let's cut these things back. 4 goes into itself and goes into that one 4 times. 2 goes into itself once and goes into that one 40 times. It looks like the denominators are all going to be 1. So what do I have here? I have a negative 100 plus, what is that? Is that 200? Yep, 200 plus 5 for a grand total of 105 feet. Well, so it looks like the answer is which water balloon went higher? The second water balloon. Done. Okay, so I did want to do one more just to reiterate some of the things from part one and reinforce the assignment and show a bunch of fraction work that might as well be refreshed by. Okay, so sounds good. I think I am ready to move on. Is that true? I'm going to say yes to that and go for it. Okay, so then the topic is going to be similar in the sense that we're still going to be playing around with quadratic functions. We're still going to be playing around with the parabola, but the format of the quadratic function is going to change quite a little bit. Now, because it's a quadratic function, it's still going to have an x squared, but it's not going to be written in the form ax squared plus bx plus c. As you can see up here in the red box, the format looks quite a bit different. All right, so it's got some real benefits, but it does just add a perhaps a layer of confusion over what our current method is for graphing a parabola. right? So our current method is analyze the A, B's, and C's and find the vertex and the y-intercept and use symmetry and maybe build a t-table if I make you find more points. Um, but then this method is going to be different. And so that I think that might add to some confusion. But it's different, but better. So in the end, you might prefer that the quadratic function is in this format where you have an a value and you have a binomial square plus some other constant. All right, so let me show you what one looks like with numbers, and then I'll start playing around with it, and we'll do a little compare and contrast with our old method and the new method that I'm going to show you. Now, big caveat on that is the new method only works if it is in this format. So it depends upon how the problem starts. Okay, so let's just roll into an example problem. And I'm going to make the example f at x. I could name it g or h or anything I want. And it's going to be 2, so a is 2. And then I'm going to make a binomial, which I'm going to use x minus 1. It does get squared. You can see that squared. And then I'm going to add to it 3, just to keep the numbers real basic. Okay, so let's say that the directions were to graph. Then we'd kind of be stuck right now because I know what the A number is, but I don't know what the B number is because it's not written like a normal descending order quadratic, and you might guess that the C number is 3, but then that'll turn out to be wrong. So because it just doesn't match up with our standard form for a quadratic, we're stuck on the graph. I suppose we could say that it opens up because that's positive and it's twice as steep as the parent function. But other than that, I don't know anything about it. So let's learn about it. Let's change it into the format that we're familiar with. And that requires some algebra skills that you already know. So what does it mean to be squared? Well, you multiply that binomial times itself. Okay, so multiplying that binomial by itself is pretty easy. We just need to FOIL. So I'll make quick work of that. X squared, I got a minus x and another minus x for minus 2x, and then there's the plus 1. So it's getting closer to standard form. I'm going to distribute in the 2 and turn it into 2x squared minus 4x plus 2 plus 3. And now you can see why I said that you'd be wrong if you think C is 3, because C is going to turn out to be 5. Okay, so now basically I've turned the new formatting, where it's written as a binomial square, into the old formatting. This is called standard form, and it's descending order, and I know my A, and I know my B, and I'll go ahead and write C this time. And I could graph it using the usual methods. Okay, so I'm going to do it. And then I'll go on to showing you the sort of the lesson as to how there's an alternative way to do it that you might prefer. Okay, so let's finish this one out. The vertex is at negative b over 2a. So that's negative 4 over 2 times 2, which turns out to be 1. And the vertex's y-coordinate is at the function when you put in 1. So that's 2 times 1 squared minus 4 times 1 plus 5. And then that turns out to be 3. So the vertex is at 1, 3. And I also know that, I'll write right next to it, I also know that the y-intercept is 0, comma 5. Okay, so let's graph it. All right, switching colors to do the graphing. I've got vertex 1, 3. I'll put vertex there. I got y-intercept 0, 5. I've got an axis of symmetry. That's right there. I've got symmetry like that. And okay, that's only 3 points, but that's maybe good enough to make a sketch of a parabola. The only thing that I'm going to add on here is if you go back to when I found my standard form equation, I would point out, I guess it's true in the original scenario too, where a is 2, but we knew it opened up, we knew it was quite steep, and we knew it was twice as steep. So twice as steep. It usually goes 1, 1, now it's 1, 2. It would normally go 2, 4, but now it would go 2, 8, 2, 4, 6, 8. So if I wanted to, I could somehow graph a couple of more points and make the parabola even more accurate. Not by building a t-table, but by just thinking about how it's twice as steep as the standard one, the parent function one. Okay, so now here comes what I think is the cool part. Talking about this new format up above, because on the set of problems that awaits you, we're not going to be doing it this way. Okay, I'm using this to show you that we in fact have a parabola when it's in this binomial square fashion. And we could do it, but that's not going to be the strategy. All right, I'm going to show you a new strategy. Okay, so to show you this new strategy, I built a Sketchpad document, and we're just going to play around with it. And in so playing around with it, I think I'll get my points across. Good news for you, though. You're going to find that it's quite easier to graph it when it's in this particular format. All right, let's go for it. So I have that format here where f of x is a times some binomial square plus k. And I also have a slider for a and h and k, so I can change these numbers, and then we will see what happens and make an observation that will enable us to graph it more easily. We already know what a does. Okay, so let me just go ahead and confirm all that. So I grab a and I make it bigger, and it gets steeper and steeper and steeper and steeper. Okay, so then I grab a and I make it between 0 and 1, and it gets wider and wider and wider and wider and wider and wider. Okay, so then I make a negative, and it goes down below. All right, so it opens down. But I'm not changing anything else. So it's like a scenario where the h is gone because I have it as 0, and the k is not there because I have it at 0. So I'm really just playing with ax squared, x squared times a. And so the vertex is at 0, 0, and all I'm changing is the steepness or the direction of it. All right, so let me get that back to 1, sort of standard parabola. And okay, now let me talk about playing around with, doesn't really matter which one I'm going to play around with. I'm going to play around with k first. So if you would, just pretend that the h isn't there. So I have a scenario where it's a times x squared plus k. So I'm going to play around with the k. Now, remember, x is the input if you were building a t-table. So these are the x's. You put them in, you put them into the machine throws number out. All right, this is the output. So the output is the height. If we add something on, then that means that the height is going to get bigger. So by adding this plus k value, it's going to affect the height. The height used to be without the k, right? Or maybe when k is 0, the height was just whatever ax squared was. But if then you add something to that, that's going to lift the height up. So what's going to happen when you alter k is that it's just going to move the parabola up. It's going to be like totally intact. It's not going to change its steepness. The vertex is going to change, but you're not going to do anything other than just move it up. But wait, maybe it'll move down when you make k a negative number. Okay, so now k is negative 3, so it's a minus 3 that's right here instead. Well, okay, that makes sense. The height used to be, when k was 0, ax squared, but then now we're subtracting 3, so the height is diminished. Not just for the vertex, but every point goes down 3 units. Okay, so now you see what k does. K moves the parabola up or down, depending upon whether k is positive or negative. And then I think that makes sense, or that does make sense, because k is this value that I'm adding or subtracting on to the function. And the function is calculating the height. So if I add it, all the heights move up, and if I subtract it, all the heights move down. That's the parabola. It moves up or down. Okay, h is a little more confusing, but let's see what happens. Now, one thing that students kind of ask a lot is, what's up with, why is it a minus sign? And this is a plus sign. Okay, so I'll try to get to that it's for convenience, really, but it seems inconvenient where one's a plus and one's a minus until you understand it. Okay, so let me try to break down what's happening with h. Well, let's see it first. Okay, so I'm going to take h, and I am going to slide it over here to the right. Okay, so that means I'm going to put in numbers like 1 and 2 and 3 and 4. So it's going to be a structure that looks like x minus 1, x minus 2, x minus 3, whatever. Okay, so moves it to the right. So if I go over here to 8, then I have a formula that looks like 1, because a is 1, and then it's x minus 8 squared plus 0, because I have that at 0, and the parabola has moved over 8. So let's take h and move it in the other direction. So that's fine. I'll just move it 3 to the left by sliding this over 3. Okay, but now h is minus 3, but then the formula is x minus 3, so that's really like an x plus 3 in there. Okay, so it's a little weird on the minus sign, but what I want to say is that if I slide it to the right, it moves to the right. If I slide it to the left, it moves it to the left. Okay, so then on this one, if I slide it to the right, it moves it up. If I slide it to the left, it moves it down. Or, I can just get all weird and go, okay, and go, if I slide it up, positive, it moves it up. And if I slide it down, negative, it moves it down. Okay, so there's some consistencies in here. If I slide it to the right, it moves to the right. If I slide it down, it moves it down. If I slide it left, it moves it to the left. If I slide it up, it moves it to the up. Wherever I stop it, I now know the vertex. Whoa. Did you hear what I said? I now know the vertex. I know exactly where the vertex is, because this one is how far I slid it to the left, so I must have gone over to negative 7.2, and this is how far it slid up, so it's 8.4. So this place must be negative 7.2, the h number, and up 8.4, the k number. That's why this format is good. It is so easy to find the vertex. Okay, so putting things back, and Okay, let's go back to 0. Go back to 0. And there it is, the parent function. New format. It's called the binomial square structure right here. Okay, so far what we have is that this h is affecting the vertex's x coordinate. If we change h, it moves the vertex in the x direction. Okay, fine. This k value is affecting the vertex's y coordinate, because if we change the k value, the vertex moves in the y direction, up or down. All right, I'm going to reiterate k, and then I'm going to try to explain what's going on with the h. So listen up carefully on this one. K makes more sense. If you add on a number like 2, then that makes sense that it moves up to, because what are you adding it on to? You're adding it on to the height calculator. This is the height. So if you add something to the height is going to get bigger. Okay, fine. But then it's weird on this one where if you move it over here to 4, say, the formula looks like x minus 4, and it doesn't move it left, it rather moves it to the right, even though it's minus 4. So let me try to explain this one. I mean, one way of explaining it is simply to say, well, that's just what happens. We could play Rene Descartes until we're like super bored with it, or we could slide these sliders and let the computer play Rene Descartes. But when I put in x minus 4, it moved it to the right. And when I put in x minus 5, it moves it to the right further. So one argument is it's just what happens. Okay, but another argument is this. When you subtract a number from x, then in order for this structure to equal a particular height, you need to put in more x's than you used to, because you're subtracting from it. So right now we're subtracting 4 from it. So in order to get to the same height that I used to be at, I need to put in more x's than normal, because every single x is being subtracted by 4. And if you need to put in more x's, it moves it in the more direction. Okay, that's the best I can do on that one, without playing around with just building t-tables and doing more sliding. Okay, so let's get this into some notes and synthesize the material and then do some samples, and I think you're going to find it very easy. The only troublesome thing is the positive and the negative. You got to just keep your eyes on the signs. So look to that as I go forward. Okay, so here is all of that conversation in math speak, and let's get into it. So this is not called binomial square, like I was mentioning a bunch of times. I was trying not to reveal the real name. I didn't want to give it away. But this is called vertex form. Okay, because you can quickly look at these h and k numbers and know where the vertex is. All right, that's good news, because that means you don't have to write this twice, FOIL it out, distribute the A, add the K, turn it into standard form, grab the A and B, and use the quick little vertex formula to only get the X coordinate. Whew, that was a lot of work. Now you don't have to do any of that. You just have to go like, what's that number? What's that number? Bam, got it. Okay, so the vertex form is great for finding the vertex. And the vertex is, that's what it says down here, the vertex of the graph is the h value and the k value. The only problem is the h value is the thing that is being subtracted. Meanwhile, the k value is the thing that's being added. And that's just a slight annoyance. It is what it is. That's what the sliders told us. Okay, and then as for the axis of symmetry, it's always been just whatever the x number is. So there it is. Okay, so making quick work of this one, if you have the parent function here in blue and you alter it by messing with the x value by subtracting h, then it's going to be sliding over the amount h. And then if you mess with the function by tacking on a plus k, then is going to be lifting the vertex, the whole parabola for that matter, up k. So the vertex used to be at 0, 0, and now it will have slid to the right h and up k. So now we know where the new vertex is. Okay, couple of samples and you'll be ready for my assignment. Graph the function. I'm just going to write underneath it, write the new format. Okay, so then I think I can quickly see that h is equal to 1 and k is equal to 6. Notice how that's not negative 1. H is the thing that's being subtracted. 1 is being subtracted. All right, so, ooh, sweet. We already know where the vertex is. It's at 1, 6. I already know the axis of symmetry is the vertical line at the vertex's x coordinate. And let's see what's up. Okay, so build a graph. I'm going to go back to green. And I have the vertex 1, 6. 1, 2, 3, 4, 5, 6. Okay, so that's 1, and that's 6. And that's V for vertex. What else do I know? From earlier experience, I know that it opens up, and it's 3 times steeper. So let's see. Let me get my axis of symmetry, because that might come in handy. I think that green pen is solid. The green line, so I'll go with black. And let's see, 3 times steeper. So it usually goes, don't forget it opens up. It's the parent function will go 1, 1. Now I go 1, 3. 1, 2, 3. And then I got that one. Okay, so there is my, oh, that was lame. There is my sketch of the, was that any better? Eh. All right, so there's my quick little lame sketch. One more thing that I would point out. I don't need you to be building a bunch of T-table stuff, but we know one thing that would happen, and that is if I put in 1, I get out 6. I'll confirm. 1 minus 1 is 0, 0 squared is 0, 0 times 3 is 0, plus 6 is 6. All right, another easy point to put in is 0. So if I put in 0, I'll do it. You get 3 times 0 minus 1 squared plus 6, which is 3 times negative 1 squared plus 6, which turns out to be, that's positive 1, so that whole thing goes to 9. So 0, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so a couple of ways to find 3 valid points, right? So you're going to find the vertex easily, and then you can use drop in 0 and find the y-intercept and then fling it over the axis of symmetry. Or you could rely on knowing that it was 3 times steeper and do 1, 3 rather than 1, 1. Okay, one more and we're out of here. Ooh, okay. So this one's going to be a little trickier because of the signs. Stay with me on the signs. This is x minus 4 squared minus 2. See what I did right there? I wrote it as minus minus. All right, so that I could model it off of the formula. So here's the formula again. A x minus h plus k. So now we know that h is -4 and k is -2. This is a crucial part of the assignment, so making sure you're good on this one. It's easier with the k. Whatever this number is, that's just a k. So that's -2, it's -2. This isn't h, that number, right? Or like this number is not h. So it's essentially it's the opposite of this number. So I like to call it the opposite game. But the logic is that it's -4, and h is the thing that's being subtracted by 4 because that's what the sliders told us. Okay, so vertex is -4, -2. And let's see, the y-intercept is 0, and I'm going to make quick work of putting in 0 here. So if I put in 0, I get 4 squared, which is 16, and a half of 16 is 8, and 8 minus 2 is 6. Okay, so let's see if we can get this all to jive up when I make my picture. -4, -2, 1, 2, 3, 4, bam. Vertex. I do know that it opens up. It's half as steep. So that is to say it's wider. And I also know 0, 6. So where's 0, 6? 2, 4, 6. Okay, so let's get some line of symmetry, axis of symmetry. Let's take this one and fold it over. How many spaces do I go? 4 spaces. Okay, so here is my parabola. And let's go with this half as much style. All right, so just confirming on the half as steep style, it would normally be 1, 1. So now it's 1/2. So my drawing is, could be better. And let's see, it would be 2, 4, but it's only half as much, so it's 2, 2. Oh, so now I'm getting pretty good. It would normally be 3, 9, but then half of 9 is 4.5, so 1, 2, 3, 4.5. So not too bad. And that would normally be 4, 16, but now it's 4, 8, 2, 4, 6, 8. And that matches up nicely. Okay, so there you have it. And next thing I'll do is put the second half of the assignment up.